Hey guys, Mr. Middleton here. Today we're going to talk about bisectors and triangles. At the end of this video, you should be able to find the missing side lengths and draw conclusions using perpendicular bisector and angle bisector theorems. Okay, and you should also be able to explain how to find the missing side lengths. Alright, so vocabulary note for this section, perpendicular bisector. There's two parts to this. Okay, first part being perpendicular. Okay, perpendicular, two lines that intersect at a 90-degree angle. Bisector, a segment or line or ray that cuts a segment in half. Okay, or into two congruent parts, but we'll just say in half. So a perpendicular bisector then is any segment, line, or ray that cuts a segment in half and meets at a 90-degree angle. Okay. An angle bisector is a segment, line, or ray that cuts an angle in half. Alright, so notice that perpendicular bisectors deal with lines, okay, or rays, okay, where angle bisector is a line that cuts an angle in half. Alright, so here we go. Perpendicular bisector theorem says if a point is on the perpendicular bisector of a segment, then that point is equidistant. It's like equal distance from the endpoints of the segment. So let's look at a couple examples on how this works out. It says given that CD is the perpendicular bisector of AB, prove that CA is congruent to CB. Alright, so this is us proving that this will work. Okay, so this is not how your problems will necessarily go through, but I'm going to use a triangular proof to show you that this will have to work. Okay, so they told us that CD is the perpendicular bisector of AB. I'm just going to walk through this really quick. So since CD is the perpendicular bisector, we know that this is 90 degrees. Okay, perpendicular. And bisector means it cuts this AB in half. Okay, these are two congruent parts. Okay. Alright, we want to prove that CA is congruent to CB. So right now, we have that AD is congruent to DB, definition of perpendicular bisector, and that these are both right angles. Definition of perpendicular. Okay. Now, the next thing that we can say, and I'll write these down, so we've got AD is congruent to DB. I can't start there. Okay, I've got to start with the given. CD is perpendicular bisector of AB. Okay, so that's given. From there, we can say that AD is congruent to DB, definition of bisector. Okay, and then we can say that angle CDA and angle CDB are perpendicular, or right angles. Okay, definition of perpendicular. Alright, so we have all that written out. We've talked about it, just wanted to write it down so we have it. Alright, now finally, we can say that CD is congruent to CD by the reflexive property and so you should see that these two triangles, CDA is congruent to CDB. Triangle CDA is congruent to triangle CDB by the side angle side theorem. Okay. Now, because those two triangles are congruent, then we can prove that, and I'll just write it up here so I don't go off the screen. Step 6, we can say that CA is congruent to CB because of CPCTC. Alright, so again, not like this is going to be all how your problems go through, but I want to show you why we know that if a point is on the perpendicular bisector, like C is, then it'll be equidistant from the endpoints of the segment that's bisected. Okay, so that's why we know that C is going to be equidistant from A and B. All right. So let's look at this example that's going to be closer to the type of problems that you'll see on a regular basis in this chapter. So it says, which segment is getting cut in half? In this diagram, we can see that CD is getting cut in half. Okay, CD is getting cut in half because we can see its markings. Which segment is the perpendicular bisector? Well, the line that cuts it in half is AB. Okay, so the points that are on the perpendicular bisector are A and B. So what that means is that this A is equidistant from the endpoints of the line that it bisects. It bisects the line CD. So if AC is 4, that means AD must also be 4. If BD is 5, B has to be equidistant from D and C, so this would also be 5. Okay, so pretty straightforward, and that's why I want to make sure that we understand why it works that way. All right, on to the back. All right, it says if a point is equidistant from the endpoints of the converse of the perpendicular bisector theorem. So converse just means that we flip the hypothesis and the conclusion. Okay. The converse says if a point is equidistant from the endpoints of a segment, then the point is on the perpendicular bisector. Perpendicular bisector. Okay, so notice that we just flipped the hypothesis and the conclusion there. All right, so it says find the value of x and explain how you got it. So notice here that F is 9 away from H and also 9 away from G. It's equidistant from the endpoints of the segment HG. Since it is equidistant from the endpoints of the segments HG, then we can say that, hey, this must be on the perpendicular bisector. Because this is a perpendicular bisector, then we can say, okay, that must mean that 5x minus 3 equals x plus 5. Plus 5. Because a bisector would cut this segment in half, or 2 equal parts. So as we solve it, we get 4x equals 8, and x equals 2. Okay, again, F is on the perpendicular bisector of HG. Okay, and we can tell that because F is equidistant from H and G. Okay. Alright, so now we're going to talk about the angle bisector theorem, but before we do, we need to make sure that we know what we mean when we say distance from a line. Or sorry, distance from a point to a line. Okay. So when we talk about distance from a point to a line, we're talking about the length of the perpendicular segment. Okay, and that's really just saying that we want to make sure that we're talking about a straight line, the straightest line possible. Okay. So if I have a line here and a point here, if I say how far away is this point from the line, you would want to find this line. You want to find this line and find that length. Okay, this would be the straightest way to it. If I asked you how far away the line was from the point, you would not say, oh, well, it's that far away. Okay, trying to find the furthest out line. You want to find the perpendicular distance. Okay, so the angle bisector theorem says if a point is on the bisector of an angle, then the point is equidistant to the sides of the angle. again, equidistant, meaning the same distance, equal distance. Oops, equidistant. So I said distance and messed myself up. Okay, so here, looking at this diagram, it says name the angle bisector. Okay, I see these arc marks here. So the bisector, the line that cuts the angle in half, is CF, or the ray. How do we know it's an angle bisector? Because angle BCF is congruent to angle DCF. Alright, since F is on the bisector of angle BCD, we'll say that, then F is equidistant to line CB and line CD. Okay, the sides of that angle. It says which symbols are necessary in order to say that FB is congruent to FD. The symbols that are necessary here. We need to make sure that we know that this is the perpendicular distance and not just two lines that we're not sure is the straightest line to the side. Okay, so these symbols let us know that, hey, this is the perpendicular distance. We can set this equal. But now that we know we're talking about the perpendicular distance to the sides, then we can say our equation as 5x has to be the same as 2x plus 24. So 3x will equal 24, and x will equal 8. Okay, and we can use the value for x to find FD. FD should be, well, we could plug it in here and do 5 times 8, which is 40, or plug it in here, get 16 plus 24, which again is 40. But it's a good check to let us know that we solved it the correct way. Okay, if a point on the bisector of the angle is equidistant from the sides, oops, sorry. I said bisector, but I meant interior. Interior of an angle. Okay, so if we just had an angle and we had a point inside here. Okay, if a point on the interior of an angle is equidistant from the sides of an angle, then the point is on the angle bisector. Alright, so for this example here, we have the question, how far from K is ED? Okay, so ED is this line. We see that K is equidistant, that perpendicular distance, from EH and ED. So K must be on the angle bisector. Because K is on the angle bisector and it's 10 away from EH, it should also be 10 away from ED. Okay, since K is equidistant from EH and ED, K is on the angle bisector of angle DEH. Alright, so now angle bisector means it cuts an angle in half. They're asking us to find the value of of X. And so, because K is on the angle bisector, we know that these two angles must be congruent, as we are assuming that. Continues through here. Okay, and so we can say that 2x equals x plus 20, or x equals 20. Okay, and then they ask us for DEH. DEH, that means we're taking this, 2 times 20, which is 40, plus 20 plus 20, which is 40, which gives us 80. DEH is 80 degrees. All right, so we looked at the perpendicular bisector theorem and the angle bisector theorem. Saw what they meant, why they were true, and then how we could use them to find missing values. All right, see ya.